Hello, everybody. Good afternoon. So I hope you everybody in this session. My name is Evgeny Lin, and I'm AWS Senior Solutions Architect. I'm helping clients to be cloud native, to move their workloads to the cloud, and my specialization is AI, ML, and data analytics. Okay, so today we're going to look into interesting emerging topic in AI/ML, and this topic will be MLOps. So let's go to the agenda. And this is the point where you realize probably you're in the wrong session, or vice versa, it's a great session. So today, what we're going to do today. First, we look and understand what MLOps is, what kind of considerations for design process, what decisions we have to make, and what key components of MLOps we can imagine. And we also look into the regulated industries, what is the most important for them in respect of MLOps, what requirements, what the main requirements they're looking into. And then we have three use cases. We look into Apache Airflow and MLFlow. Like a couple of slides, just give you high-level overview, understand whether you can use it for your project or not, what are the use cases. And we have deep dive into implementation of MLOps with Amazon SageMaker. And here we are going to have a demo. So it will take 45 minutes. You are going to have, at the end of the presentation, 15 minutes for your questions in YouTube channel. And anyway, after the session, you can contact me on LinkedIn. You can go also to the GitHub repository. I'm going to share the links, and you can contact me through GitHub as well. Okay, let's start. So what is MLOps? If in one sentence, MLOps shows us the path to production. And what is the path to production? One can say it's ML code. The data scientist has notebook, the model trained, delivers great results, so we're fine. So this is ML code you can take and move to the production. However, the reality is much more complex, because to come to ML code, to be able to run the ML code, and to be able to come to the model and to train model and to validate the model, you have to do many other things, like you have to configure your data access and permission. You have to configure your development environment, testing environment, production environment. You have to collect the data. You also spend a lot of time in the feature extraction management. You do the data analysis. You also would like to implement some reproducible workflows and pipelines around your model and data processing. So you need a tool for flow or orchestration. You also have to manage your compute requirement, the instances where your model runs, where your data processing run, and so on. You have to also take care about your serving infrastructure, potentially hyperparameter optimization. Production monitoring is very important. And last but not least, the model debugging. Understand what's going on, the model explainability, and so on. So you see, around a normal data scientist work, we have a lot of other actions, components, and requirements that also should be fulfilled. So what kind of problems we are going to solve with MLOps? Referring to the previous slide, and also looking at the experience from enterprises and from other companies. Again, the first thing, we get models into the production. Then we would like to productionize our workloads and ML workflows. Very important to look into security, automation, reproducibility of ML workflows. The components like model registry and tracking and experiments, to have it in one place, also very important. Data lineage, to understand on what data sets your model has been trained, and how your data goes through the processing pipeline is also extremely important. We also would like to integrate our ML environment into existing CI/CD pipelines, for example, in your Jenkins pipelines or your GitLab pipelines. And as a big component, a big topic, very important, is a monitoring. So the constant monitoring of the model into the production and see what process you have there, and feedback this information back to your model, back to your development. Last, probably very important thing, MLOps also support and encourage multidisciplinary teams. And MLOps gives you possibility to integrate work or distribute work between different teams. If we look at ML development and world today, so according to the Gartner study, a little bit than half of all projects make it into production. And it takes 9 months on average to deploy the model from pilot to production. It costs a lot of cost, specifically for the big organizations. They're not very flexible, not very agile. They have to integrate every type of the development or models into existing governance, security, landscape, into the applications, and so on. If we look what is going on and what is happening in couple of years, we'll also see that, again, according to the Gartner, 75% of all organizations will shifting from just doing something with ML, probably playing around, do some pilot projects, into really developing and delivering models and something that brings business value into production. So operationalization of the AI. And if we look at what is the main impediments and problems for organizations to do the adoption, to implement IML, we see the first, the two major points or blockers are integration of the IML solutions into existing system and complexity of all these different dependencies between different artifacts, complexity of what's going on around model, as we've seen on the first slide. And it's also the second biggest problem is the security. And just keep in mind this security and integration. And when we come to regulated industry, we see these main topics that come in always along, they come in every discussion. And this is main challenges for regulated industry that we see and that prevent from effective adoption of AI/ML. The first challenge is security. Any enterprise and specifically regulated industry like insurance and financial area, banks, and so on, they would like to create secure and compliant, legally compliant as well, and resilient ML workloads. And the second challenge that we really have to look into along implementation of any ML project is integration into existing landscape, supporting and growing together with the development organizations, so be able to accommodate these frequent changes in the development organization as an overall organization of the enterprise, and also to be compliant with the existing governance and operational model. So it's not a very easy task. So how are we going to do it, and what area we have to consider and evaluate before we start implementing our MLOps platform? I'm saying platform because MLOps is not only one component, it's not only one orchestrator or workflow manager. It's an end-to-end collection of components that work together and deliver something that we call MLOps. So it works together with your existing DevOps, works together with your existing security department and your security processes. So what decision first we have to make? And these decisions normally coming from the organizational side, they're coming from the business side, they're basically not technical. First, we understand what kind of access control and permission approach we are going to implement. This is something that is normally given from the governance body or from some security body. So too broad options, a centralized or federative access control. It has a direct implication of what kind of data access pattern you implement, how you manage your data access, how you manage access to your models, to your code, and so on. Then you define your roles, who your key user personas, like data scientist, business analyst, data engineer, DevOps person, and so on. And these key persons, these roles should be integrated into security on the one side. On the other side, it gives you also understanding what processes you have to implement. Data access control is very important. Before you start implementing a MLOps platform, you have to understand and also handle and manage your data access control. If we're talking about cloud setup, and it's important for any cloud, again, we understand, is it single account or it's multi-account setup? For simple projects or for small companies, single account works fine. If we go into enterprise area and start implementing complex project with multiple teams, as normally what we've seen is a multi-account. And again, this multi-account structure can be very different. You can implement, for example, the central data account for the data storage, the central account for the permission management and for the tooling, and each of the data science teams can have own account, just one of the examples. Another example, you can implement account mesh, meaning that every account is responsible for their own data, for their own workflows in ML, for the tooling, and so on. So this is first the big decisions you have to make, and they're coming from the business side. And then we start looking into the technology. Generally, we have to understand and select 4 different frameworks. It's fine if this all 4 areas delivered from the one framework, but normally it's a collection from different products, components, and technology. So first is our ML and data science. What kind of framework we're going to use, how we're going to implement our pipelines there. The second is a classical DevOps CI/CD, how we build our models, how we run some additional scripts, how we move models from development into registry, from registry into test, how we test models, how we move them into production. It's normally, if you have already something there, GitLab, your Jenkins, your TeamCity server, or something similar. ML workflow and automation is a component that's responsible for the orchestration of different tasks that you're going to implement in your ML pipeline. And so you implement task, you monitor task, and you also ideally would like to be able to move your components between environments with the least effort. And last area that you have to understand what framework, technology, provider you're going to use, how you store your data, how you structure your data lake, how you get in data directly from data lake or through data files, how you process your data. Again, before you start your feature engineering, your data analysis, you will potentially have to process your data, pre-process your data. And these components not necessarily related directly to ML or something the data scientist sees. But this is part of your ML platform, and important part. Now, when we are moving to more, so we understand now what we want to implement, what our decisions, how our environment looks like. We made some technology choices. When we now look at MLOps platform, and any good MLOps platform contains the following components. So first of all, should be some kind of integrated environment, collaborative environment for the data science work, development, experimentation, collaboration, and so on. Then we should have compute environment to run models, to run containers there. So not everything you can run on your local compute on your laptop. Sometimes you need distributed training and some powerful compute. For example, if you use some cloud compute for running models. Then we come into more of the components that's specific for MLOps. You normally would like to have a model registry. So it's a normally a centralized repository where you keep all your models, and you keep also version of the models, and you keep the data lineage there. And ideally, this model registry will support the life cycle of the model. Next component is the feature store that manages your features and allows you to collaborate on the feature, have feature history, and so on. And further components are you need some model deployment, workflow tools. You need monitoring. You need hyperparameter optimization. You need to manage your data, and workflow orchestration and pipelines. And there's a slide. There is a lot of ontology, how you can structure, slice, and dice different components of MLOps platform. This is good to refer to different components. And just to close the discussion about how we built MLOps platform, also important to define what main requirements or main key feature any good ML platform should deliver. And here we have the 7 topics. Reusability, meaning that we would like to reuse as much as possible from something that we created. Everything should be reproducible. So if you have the same input, same data, same initial conditions, ideally you should have the same results. Security, very important. Again, it's a job number 0. Auditability, everything should be logged, ideally versioned and historized. You have to understand the full history of your changes, not only on the source code, but also on the data, on the features and the model. Governance. So it should be oversight what's going on there. Ideally, data scientists should use approved components, not implement something out of the blue and then use, and you're not sure is it compliant or not. What's specifically important for regulated industries. Ideally, you would like to give people something which is already tested and compliant and monitored to use, and this is governance. Scalability also important. When you move from 10 users to 100 users, 1,000 users of your model, and you move from megabytes to gigabytes to petabytes of the data, the whole platform should be able to scale together. And of course, flexibility. You're really interested that your platform can accommodate almost any ML framework. It's not tightly coupled with one specific implementation or one specific vendor. Now, when we go to the application of all this, so what we have now on the market, what is very popular? MLFlow, we'll talk a little bit later about this. Apache Airflow is more simple than MLFlow, but it's great in its simplicity. You can start doing orchestration of the workflows and some complex things in pipelines really within minutes after the installation. Kubeflow, it's based on the Kubernetes, it's ML toolkit. And then we have 2 AWS specific implementation. Amazon SageMaker. Amazon SageMaker will also talk later, and also we see a small demo. Provide you end-to-end environment for implementing your MLOps. AWS Step Function is something that gives you really good integration into your cloud and also provides a lot of functionality and capabilities. How can you implement, orchestrate your pipeline? So when we're looking at Airflow, as I say, main reasons why it's so popular. So it's extensible. You can easily implement new operators. Operators are reusable, and you have a huge library of the operators. It also supports multi-cloud. You're not dependent on one single provider. It also has a simple workflow management based on the directed acyclic graph, meaning Airflow automatically creates a graph of the workflow, how your workflow executed based on the dependencies between tasks. So you can implement really complex workflow and run complex workflow. And it's Python based. So it's an imperative. You say how you would like to do something, and you can implement your operators based on the Python. And this is open source and have an active community. You have one of the flavors of the Apache Airflow, and which is called Amazon Managed Workflow for Apache Airflow. It's basically the open source component just taken and packaged, and they run on the AWS. And you have out of the box kind of security, you have installation. So if you use AWS, if you have your workflows in the cloud, AWS cloud, makes sense to look into the managed Apache Airflow. Just gives you out of the box a lot of heavy lifting. You just have to focus only on your implementation of your tasks. And as I said, the heart of Apache Airflow is directed acyclic graph of your tasks. And this is how you get the things done. Apache Airflow, very lightweight, very easy to start, but it doesn't have advanced capabilities like advanced tracking, the model registry, the integration with other things. But if you would like to start with MLOps, and you starting with MLOps normally means you focusing on the getting reproducible pipelines and workflows, and Apache Airflow is a good start. Then we go to the MLFlow. MLFlow is another very popular open source platform, and it provides you end-to-end capabilities for almost every aspect of the MLOps. It contains 4 main packages or 4 main components. First component is the tracking. So you keep track of your experiments, of your data configuration, your model training, your models, results, and so on. You can also store there any artifacts like parameters, code, model metrics, and so on. And later you can go to the UX and you see these results visualized. You can see the development of your model, for example, metrics over the time on the different data sets and so on. This is really essential part of any MLOps platform. Then you have a project component, which allows you to create portable packages of your work. So if you create some MLOps workflow or ML workflow, you can package it into the specific format, and then you can reproducibly run it almost on any platform. Another 2 very important things that coming together. It's a models and the registry. Registry is a central repository for the model storage, and there you can do as a data lineage. You do the model versioning. It supports stage transitions, so the model lifecycle from like pending to the tested to moving to production, archived, and so on. It also supports model annotation, so very powerful tool. And the models, it's with MLFlow, you can keep models in different like formats, different flavors, depending on framework you are using. And it also supports the different storages where you store your models. So for example, in specific case of AWS, you store it on S3. What is also good with MLFlow, it supports multi-cloud, it's library agnostic, everything accessible through API and CLI. It's scalable. You can work with a big or the large data sets. It supports Spark clusters. It supports large number of experiments, and it's very easy to use through the API and CLI. As I said, MLFlow is a powerful tool. It provides you basically end-to-end components and end-to-end capabilities to implement your MLOps. Again, it's a very good candidate to look into to start with. It's a lot of documentation. It's an open source community. Keep in mind that open source version has some limitations, specifically for security. All users are able to see all data. So if you want to integrate into your corporate environment with with strict security policies and so on, you probably have to look into one of the vendors that provides MLFlow, like Databricks and so on. And yeah, the heart of the MLFlow is a tracking server that keeps track and stores all your metrics, artifact, metadata, models, parameters, and so on, and model registry. And model registry, as I said, it's everything about your model. You implement or handle your model lifecycle with this registry. Okay, and now we come into to the last component or last areas I would like to show. It's Amazon SageMaker. It's also another option for implementing your MLOps. So Amazon SageMaker is not MLOps platform. It gives you end-to-end and fully integrated tool for the whole AI/ML development. It has also specific components that support MLOps. A good thing about Amazon SageMaker is all integrated in one environment. Plus, it's all integrated into existing non-ML specific security controls, networking controls, monitoring, and so on. So all services, is all 200 services that you have on AWS Cloud, you can access from your SageMaker workloads quite natively. And if your cloud is AWS, it's a great choice to implement your ML environment. Specifically for the MLOps, what we have here. The first is SageMaker Pipeline. SageMaker Pipelines is a workflow orchestration, and you can create, again, it's similar to Apache Airflow. You can create a direct acyclic graph of your tasks, of your steps, so we call it steps. And pipelines automatically creates the graph based on the dependencies between steps. Then it's integrated in CI/CD automation, so you can use any Git supported repository, you can use Jenkins, or you can use AWS native code pipeline services. It has also centralized model registry, the model explainability component that explain what features kind of have the biggest impact of your model performance and much more. It has also built-in model debugger. It has built-in feature store where you can keep track of your feature and scalable. You can scale up to millions of features and millions, hundreds of millions of rows in the storage. And another very powerful component is the trials and experiments. Trials and experiments keep track of all your data science experiments, of all your model training runs, of all your model validation runs. You can also access it through UX or through API or command line interface. Also very similar to MLFlow. So you see this, the different approaches or different ecosystems, they more or less go into one direction and provide the same set of their key requirements that we looked at the very beginning of this presentation. Okay, now I would like to go to the SageMaker, and more specifically to the SageMaker Studio, which is integrated interactive environment for data science. This presentation based on the public GitHub repo. So you can scan Q code and go to the GitHub repo, write commands there. You can clone it and work on your own pace if you're interested in to look how you can implement secure MLOps platform. Okay, now I'm going to SageMaker Studio, and we'll look what we have here. This is a solution that is implemented in SageMaker based on the components that on the different services that are integrated in SageMaker or services that we have in AWS Cloud. First of all, so this is MLOps platform, and it contains the following parts. So we have a portfolio. This is data science portfolio with governed and controlled components. These components can be designed and developed by different teams and then delivered as a portfolio, as a product portfolio into the SageMaker environment. And the data scientists can just browse this portfolio through website and then instantiate this component into machine learning environment. And this component controlled in the way they're pre-designed and have all necessary security and governance controls that any of your governance body would like to implement. So this solution implements two products within this portfolio. One product is a pipeline for the model building, training, and validation, and then registering in the central registry. And the second component, we call it project, implements the model lifecycle. So as soon as you approve model in the central model registry, the model gets automatically deployed into the test environment. It can be different cloud account or can be just a different compute environment. Then model tested, the automated scripts run there. And after you have test results, a human can approve it. And after model approval and test approval, it's deployed into the production. And it's everything done within a single pipeline. If we take a closer look into these two projects, the first project, as I say, it's a build, train, and validate model. And this project contains two big components or built on two services. One is a pipeline. As I said, this is orchestrator, as this is a service or technology that allows you to create different steps. You can implement different tasks in the step. You can implement, for example, like Python script and run your Python script as a separate step. Or you can use existing containers, processors based on the popular framework. For example, one of the steps, in this case, training step, can be running XGBoost container with XGBoost implementation, which just takes your data, trains the model, calculates the metrics, creates the model, stores the model on specified storage. Then next step, it goes to the next step, it evaluates the model, and after model evaluation based on the performance of your model, for example, you would like only to keep your models which they have accuracy higher than specific threshold. These models get registered in the central model repository, and after that you can start doing something with this model. So you can evaluate it one more time, you can look into the data, or you can deploy your model into the production. And this is implemented through SageMaker pipeline. We'll take a look 2 minutes later now how it's implemented specifically. And the next component, it's implemented using AWS code pipeline. You can also implement it in Jenkins, for example. This is CI/CD pipeline. And this CI/CD pipeline has a classical launch mechanism. As soon as any changes in your project code repository, which contains basically your pipeline, if you have any change here and the change is committed and pushed into the repository, the pipeline launched, and the machinery starts here, which basically gets your code, builds the pipeline, runs the pipeline, waits till the pipeline completion, and then can do some things based on the result. This is implemented in the classical CI/CD. So it is no ML magic here. So ML magic happening here in pipeline. Okay, let's look what kind of components we have in SageMaker to support your MLOps, as I said before. So very important, the projects. And projects, this is components that are created somewhere outside and then delivered into your SageMaker environment. So this is exactly this reusable, controlled, and governed components and data scientists can use. And it happens very simple. You just click create project, and you have some project that delivered already like a predefined together with any SageMaker Studio, and you can use out of the box. You don't need to develop it. And all this project, it's around MLOps, exactly what I was showing right now. Or you can create your own projects. And this, for example, 3 projects that I created in my environment, and can be created outside with different team and delivered to the data science environment. And for instance, instantiation, I just click select project template, and you can provide some parameters. This is all configurable. You define what you would like to have here, and this is common and regular mechanism. It works through CloudFormation if you're familiar with AWS terminology. So here you can define the parameters that you would like your users to provide for this project instantiation. After you provide these parameters, you instantiate the project. And then if you go to the one of the existing projects, you see that all projects resources and artifacts are here in one place together. So you have the code repositories that the project creates, you have pipelines, you have different experiments, you have also the model. This is exactly this central model registry. You can go and see what kind of models you have here. We have only one version, which is approved, and so on. And you also see endpoints, and points is inference endpoints already runtime. If we go to the pipelines, this is exactly ML pipelines. So we have a presentation. Okay, this is one is simple. I would like to go to one more interesting. Yeah. So for the pipeline, you have clear the all metadata. What is this pipeline about? You see the representation of the pipeline. And you see you have a different steps. For example, here we have data pre-processing. This is Python script. Then we have the training of the model. Here we use the predefined container with the XGBoost implementation. Then we have the evaluation. Again, using the test data set, we run the Python script and see how our model performs. And then based on the evaluation, and we take MSE metric here, we decide whether we would like to go further with this model. And in this case, we register this model, or we say, no, we don't need this model, we just throw it away. So this is metadata, and then how your pipeline is structured. So you can create quite complex pipelines, and execution engine also decides which steps are connected based on the dependencies, and you set dependencies with the steps. The execution engine also understands how the data moved between steps. So normally what you do, you say the data output from this step is a data input for this step. So this is output to input, and this is dependency. You don't need to specify this dependency explicitly in the code. You just say data output here is data input here, and then the execution engine understands this dependency and creates a proper pipeline. If some steps can be done in parallel, the execution engine will run the steps in parallel as well. So it's quite intensive, extensive system. Then, of course, you can define your parameters for the pipeline, so the parameterizable, and have some default values, so you can set values in the runtime. And then it keeps track of all execution of your pipeline. So if you go to one of the execution, again, it shows you what's happened here, clicking on each step. You see the lot of details here. Again, this is your auditability of the system, where everything logged and versioned, and you know what is coming from where. You have your inputs, your all outputs, you have your logs, you have your output of this specific step, and you see the output. We have just separation. We have 3 data sets, which is validation, train, and test, and taking the different step. For example, evaluation, you have a different set of parameters, different set of inputs and outputs. Okay, and the last thing that I would like to show here is experiments and trials. As I said, everything what you do, like your model run, your model training, your data processing, your AutoML run, and so on, you can look at experiment and trial, and it builds a hierarchy. So the bigger things are experiments, the smaller things which contain or belongs to one experiment is trial. It keeps a full track of record what you were doing here. For example, just like to find a nice one. Yeah, this is, for example, it's one of the AutoML runs where you run multiple tries on the same data and running multiple training jobs, trying different models and trying to estimate what models performs the best. And in this case, this specific case, we see that the engine, AutoML engine, which also part of the SageMaker, tried different models, I think about 20 different models with different parameters. And one model was the best, that was kind of selected based on the objective metric. And I also can see all information about this model. It's what I said before about model explainability and debugging. For example, this is all automatically generated, so there's no human interaction involved. That gives you really powerful jump start with your model development and UML project. It also generates automatically some notebooks for the data pre-processing, the model processing, and so on. Again, everything you have the full data lineage here, so understanding what data is the source data with the model, what kind of shifts and validation and testing data you done, and so on. And you can, for example, directly from here, you can deploy your model into the endpoint. Okay, I think at this point we done with demo. As I said, you can always go to the GitHub and go with your own pace, look into the notebooks. There are a lot of code delivered there, and you can reuse these components. The last things are MLOps resources, so just a selection. When you would like to start your MLOps journey, if it's just new for you or you already experienced there in MLOps, I think this will be equally beneficial for you. So on one side, there's some selection of the blog posts. There's much more. Some blog posts is about Amazon SageMaker, some blog posts about using MLFlow, some about Airflow. If you would like to have some hands-on experience, I encourage you to look into the workshops. Again, different technologies, and before you decide to use something with your production system, you can safely try at least 2-3 different approaches for the MLOps. Airflow, MLFlow, Amazon SageMaker, and so on. You have also ready-to-use solutions. So if you go to any of this link, you can just take it and deploy on your environment and use it, and it gives you really jump start with a lot of things pre-configured, with security proper configured and tested, with the different user roles that you can already use one-to-one in your environment. So I think at this point, we're ready, and I'm available for questions on the YouTube channel.